making very good progress on my Curta 3D printed calculator project. It's coming along nicely, but I have encountered a bit of a mystery with this that I'll come back to in a few minutes. It's something that I haven't really got to the bottom of. I found a solution to it, but I'm not quite sure exactly why the issue occurred. But as I say, I'll come back to that in a few minutes. In the meantime, I'm working on the outer cover. So I'm sanding these down and painting them, as you can see. So I've just got the main one to do. I'm halfway through sanding that down. Once I've done that, that will be all the parts finished apart from one, which again I'll come back to in a few minutes. I've made some other changes to this. So one, I've added a ring to the crank. So this is, it's not painted on or taped. This is a 3D printed ring. So this is obviously 3D printed in red PLA, and I did another version of the crank with a recess on the bottom, so this just kind of pushes onto that recess, not glued on, it's just a tight fit and it just pushes on, and that indicates a subtraction mode, so it looks quite nice. It's hidden when the calculator is in addition mode, and it appears when you pull the crank out. So that's a bit like the original was arranged. And also I was using O-rings on some of the shafts, some of the drive shafts, to position the gears until I got them in the right place, because obviously with O-rings I can just slide these up and down the shafts until I've got the correct location. So once I'd got everything in the right location, you can now see that what I've done is reproduce some clips very similar to the original calculator. So it's just a ring, 7.2 millimeters outside diameter, 4.9 inside, 2.9 wide, and with a 30-degree cutout. Now with hindsight, a 45 or even 90-degree cutout would have been better. They're a little bit snug to get on there. You can get them on and off alright, it's just a bit tighter than it needs to be, but they do snap down into the grooves very nicely, and it holds everything in the right place. So talking of things being in the right place, I got these modifications done, and then I encountered a bit of a problem. I was going through and checking that all the gears were in the right place and that they aligned with the step drum correctly and were giving me the correct output. And these are all fine, all the input register gears are fine, including now the 3 on the end. But I was having a bit of an issue with the way the calculator was behaving, and that is the counter was just making up numbers. It was coming up with just weird behavior. And the way the calculator should work is with the reversing lever, that's this lever in the up position, every time you rotate the handle on the calculator, the counter, that's the silver section, should increment by 1. That's when it's in addition mode. If you put it into subtraction mode, then every time you turn the handle, the counter should decrement by 1. But it wasn't doing that, it was just, as I say, making up random numbers, and all the digits were changing fairly randomly. When you put the reversing lever into the down position, what should happen is the reverse. When the calculator is in addition mode, every time you turn the handle, the counter should decrement by 1, and when you put it into subtraction, the counter should increment by 1. Now, I mentioned before that the calculator can't actually do subtraction as such. It uses a mechanism or a system called 9's complement. So in this calculator, the counter is only incremented by normally by modifying the first digit. But this alignment of all the gears allows you to actually increment all the digits by the same amount if you want to. Now, to use 9's complement, what we do here is we increment all the digits by 9, and then any carries will ripple through the counter afterwards. That effectively allows us to decrement the counter, and that's how the decrement works. It just effectively uses 9's complement. But it also needs to be able to increment the counter by 1, and it does that in 2 different modes. So we'll go over how this is supposed to work and the problem that I found. So I've got a prototype step drum here, and this top section is what we're interested in. This other section is what's used for the normal calculation. and this top section is used for the counter. And it's effectively got three sections. It's got the top section, so there's three sections in here. The top section has one tooth, the second section has 9 teeth, and the bottom section again has one tooth. So this is used to add 1 or increment the counter by 1 in these two positions, or to increment the counter by 9, in other words to decrement the counter when the center section is used. So if we now look at an example of the gear, this is on the first digit of the counter, then with this step drum in the down position, which is in the add mode for the calculator, and the reversing lever in the up position, and what happens is it runs like this, hopefully you can see this clearly, and just one tooth hits this gear, and it does that every time the calculator spins, and it increments the counter. And then the counter handles any carries to propagate the number as it's supposed to. So that's in normal addition mode with the reverse lever in the up position, so it sits like this. But when we pull the crank up to put the calculator into subtraction mode, then the 9 teeth align with the center gear, and that's what causes it to increment by 9. Okay, so that's the two modes with the lever up. It's either in this position or it's in this position. So when we put the reversing lever down, so if the calculator is in the add mode with the step drum in the down position, and we push the reversing lever down, then again the middle gears line up with the 9 teeth, and that causes the counter to decrement. So in other words, it does the reverse of what it does in the up position. And then when we pull the crank up and put the calculator into subtract mode, it pops up here, and then just the bottom tooth, single tooth, causes the counter to increment. So with the reversing lever in the up position, the counter increments once per revolution when in addition mode, and it decrements once per revolution in subtraction mode. But with the reversing lever down, it does the opposite. In addition mode, it decrements the counter by 1 for each rotation, and it increments the counter by 1 for each rotation when in subtraction mode. However, mine was lined up something like this. It was just sitting in a very weird position, and when I put the calculator into subtraction mode, it did all sorts of weird things, and when I pushed the reversing lever down, again it did very weird things. Now I have to assume that the calculator, based on the STL files I downloaded, originally worked, so I'm not quite sure what the issue was. So I started looking into this, and I realised that this was in the wrong place. The reversing lever was just in the wrong place. If I rotate the calculator, you'll see the 9 tooth section of the step drum come round. It is now, by the way, in the right place. I have moved it. And you'll see this comes round, and you'll see, hopefully you can see, this section here is where we're looking. The single tooth at the back end, this tooth, is going to hit the bottom gear and increment the counter, which it does. And that's exactly what it's supposed to do. When we put the calculator into subtraction mode, then those 9 teeth should now be aligned with the center gear, which means that it's also aligned with the other gears on the other 5 digits. As we bring this round, you can see, hopefully, it is now aligned and causes the counter to decrement. And then when we put, sure, we're in the home position, and when we put the reversing lever down, put the calculator back into addition mode. Now again, in this mode, the 9 teeth should be aligned with the center gear and cause the counter to decrement, and as you can see, that's exactly what it's doing. And when we put the calculator into subtraction mode, it should increment the counter by 1, but this time it will use the top gear, which is what it's done. So that's now working fine, But what I found was that the lever was going into the wrong positions. But to get this to work, I've lengthened the top spacer by 2.5 millimeters, and I've lengthened the bottom spacer by 1.5 millimeters. So in other words, I've shortened the throw of this lever by 4 millimeters. Now if we think about this, the travel of these parts, put it the same way around, means that with the reversing lever in the up position and the calculator in the subtraction mode, the center gears line up. So in other words, when both are up, the center gears line up. With the calculator in the addition mode, in other words with the step drum down, and the reversing lever down, again the center gears line up. So in other words, the travel of the reversing lever has to be the same as the travel of the step drum, because they at some point move like this. So what controls the travel of the step drum is this arrangement at the bottom, and if we measure this, so get a set of calipers and measure from the bottom of that slot to the bottom of the other slot, and it's about 8.5 millimeters. But if we get the shaft, this is the shaft that the reversing lever runs on, we've got these two dimples. But if we look at the dimples, they're not spaced by 8.5 millimeters. And if we measure this, they're actually spaced by 12.5 millimeters, which is 4 millimeters greater. In other words, these are spaced 4 millimeters too far apart compared to the spacing that's on these slots in the step drum. So these should be the same for them to line up correctly, and clearly they're not. Now with these spacers in that I've made, it actually brings the travel down to 8.5 millimeters, and because of the relative lengths that I've made the spacers, then it's putting the gears in the correct locations. What I need to do, of course, is make a new shaft up with the indents in the right place. But what I can't figure out is how it originally worked. I checked this, and this is it's not an error in the printing. This is what the STL file shows. So I can't quite figure out exactly what the issue is and how it originally worked. So anyone that's built one of the originals, did you have the same problem, or did yours work straight out of the box? I have also been making some other changes to bring the friction down. So as an example, if we take one of the drive shafts, I've machined in this bottom face, the bottom half millimeter. I've taken it in by about 2 millimeters, so it's kind of got a step on the bottom, and that's just to reduce this contact area on the bottom of the gear. So where it's in this top assembly, it now has much less surface area, cuts the friction down, and it spins a lot more freely. In fact, now when I turn the calculator, it spins very freely indeed, and there's almost no force required to turn this handle. So it feels actually very like one of the original calculators, just on a bigger scale. And as I say, there's almost no resistance to turning this lever at all. It just turns extremely freely, but it is actually working. So I'll try and demonstrate this. It's quite difficult without the housing on. So we'll set 3 on the input. So we've got 2, 3, so it's going to add 23. So if we keep track of the number, every time I turn this, try and do this without getting completely obscured. So every time we turn this, notice that the count is going up by 23. Also, if we look at the turns counter, sorry, I've got the reversing lever in the down position. If we look at the counter, you'll see that it is incrementing once per turn. So it's 26, 27, 28. So it's working the way it should. If we put the calculator into subtraction mode, it should now subtract 23, and it should decrement the counter, which it is doing. Sorry, you can't see this very well, the lighting's not really good. I'll try moving this light. I hope you can see that better. So 863 minus 23 40. Try it one more time. 17. One more. 94. So that's working. So as you can see, it's working exactly the way it's supposed to. Clearing works. As I say, it's quite hard to handle like this because there's nothing really to hold on to. Once I get the other parts fitted, I'll do a better demonstration, but it does now seem to be working. The only thing I need to do is make up a new shaft for the reversing lever. The rest of it is working fine, and as I said, it's very free to turn. Even when it's doing big calculations, if we set digits all the way up, it still turns very nice and freely, and there's no real resistance to it spinning. So hopefully I'll be able to get this wrapped up in the next video. Just got the outer covers to finish off, new shaft for the reversing lever, a few small jobs to get sorted out, and in the next video hopefully I'll be able to show a fully working calculator.